All right, what we're going to do right now is we're going to go through some inverse trig derivatives and see just how we use the chain rule. The key thing is that we are going to go with this. Now, if you don't know, you'll find in books and online all the different inverse trig derivatives. And I'll have another tutorial on if you want to know how you can actually find these. But these are the basic ones. When you have arc sine, arc cosine, arc tangent, arc cotangent, just be aware that this also means the inverse. All right, when you look at inverse, this is where you have the little -1 right there. Okay, and when you're solving those. Okay, so we're taking the derivative of all of these inverse derivatives. Okay, of cosine, tangent, and so on and so forth. Now, you want to write these down. You want to memorize those. Okay, and you can find these in your book. Find them maybe on a sheet. But we have all these different ones. Okay, so if you want to pause this video and write all these down, that would be cool. All right, but we're going to be using those, all right, and finding the various derivatives using chain rule. So let's start off. We're going to find the derivative of dy ds. S is our independent variable. So we see that our outside function is the inverse of secant. Now this is also known as arc secant, all right, of 5s. Okay, 5s. My 5's and s's look the same, so I apologize for that. But what we have right here is we're going to take this derivative, and we're going to first take the derivative of the outside, because we see this is our u, all right? So using the chain rule, we can see u is going to equal 5s. And so we really have the y equals, all right, inverse secant of u. Well, what's the derivative of the secant function? Well, the derivative of secant, and I have it over here if you didn't know, is going to be 1 over, all right, u, all right. Sometimes you'll see an absolute value here. When you don't have this as the domain, for this one, x has to be greater than or equal to 1, so it always has to be positive. So that's why sometimes you don't need an absolute value there. But when we have that, sometimes you'll see an absolute value for this particular derivative of the arc secant, arc cosecant. But then we're going to have u squared minus 1 times the derivative of u. Okay, so let's just plug all this stuff in here. The derivative of u is going to equal 5, all right? And so what we have here is 5, let's replace that little substitution, over u. What's u? U is 5s, all right? The square root of 5s squared minus 1. Bada bing, bada boom, you got your answer. We can do a little simplification. The 5's do cancel out right here. And we can have 1 over s times the square root of 25s squared minus 1. Bada bing, bada boom. And we have our answer. All right. Another one. We have cosecant. Cosecant is very similar to secant. Same thing. You see this inside. So this is the same thing if you'd see arc. All right. Cosecant of x squared plus 1. We're going to use a chain rule. We see you have a u right here, which is going to be what we call x squared plus 1. And so this can be written as arc cosecant of u. To find this derivative, now just like when we take the derivative of all trig functions that begin with c, this can be negative. This one also can be negative. And it looks very, very similar to the secant, okay, secant. And so what we have right here is going to be -1 over, once again, u, so value the square root of u squared, all right, minus 1 times derivative of u. What's the derivative of u? That's 2x, all right. And so we're going to just replace this with -2x over the quantity, all right, x squared plus 1. Replace that u right there. And then we have x squared plus 1, that quantity squared, minus 1, and that's going to be our derivative. Okay. We can do another one. I'll give you another one. Let's say we have tangent. Tangent is a very popular one. So let's say we have the derivative, all right, of arc tangent. Okay, I'll just call it arc tangent of 7x squared plus 3. Okay, and we have this. Find this one out, all right. Once again, we're going to take the derivative of arctangent. Now, arctangent, if you refer to your table, if you want to pause this and figure it out, you can. All right. But what we're going to do right here is arctangent is, we won't just say our u. This is our u again. Chain rule, x squared plus 3. And so we're going to take, so we have arctan of u. And so the derivative of this, all right, with respect to x, is going to be 1 over, all right, 1 plus u squared times, all right, u prime. That is the derivative of our tangent. Plug in our u, we find u prime to be 14x, and so we have 14x, because that replaces it right there, over 1 plus the quantity, 7x squared plus 3. All right, and that's it. All right, pretty much solving all these arctangents and inverse tangent or inverse trig functions, the derivatives of those, using a lot of chain rule. Memorize the formulas. I'll show you in another tutorial of how you can generate these formulas, but easiest is just to know them. All right, or be able to reference them easily. All right, well, I hope this helps you out on how to find our inverse trig function derivatives. And yeah, good luck and God bless in the rest of your problems.